Welcome to this scientific exploration of visualization and its effects on outcomes. Today we'll examine whether visualizing success can actually influence reality, and what modern physics, psychology, and neuroscience tell us about this fascinating question. Can you achieve a goal simply by visualizing it strongly? Can visualization create new effects in the universe? These are bold claims that require rigorous scientific scrutiny. First, let's define what we mean by visualization. Visualization is the mental practice of imagining yourself performing an action or achieving a goal using vivid sensory details. When you visualize, specific neural networks in your brain become active, creating patterns of electrical and chemical activity remarkably similar to actually performing the action. Let's examine what rigorous psychological research has discovered about visualization. The findings are nuanced and scientifically fascinating. A landmark study published in the Journal of Neurophysiology examined basketball free throws. Researchers divided participants into 3 groups: physical practice only, mental practice only, and no practice. The results were striking. Physical practice improved performance by 24%. Mental practice alone improved performance by 23%. The control group showed no improvement. This demonstrates that visualization can genuinely improve motor performance. But notice, the participants still had to physically attempt the task. Visualization alone didn't put the ball in the hoop. Now here's where it gets interesting. Psychologist Gabriela Oettingen conducted extensive research on positive thinking and goal achievement, published in multiple peer-reviewed journals. Her surprising finding: people who only visualized positive outcomes were less likely to achieve their goals compared to those who also visualized obstacles and challenges. People who visualized success combined with planning and obstacle anticipation achieved their goals 65% of the time. Those who only visualized positive outcomes succeeded only 38% of the time. The mechanism is fascinating. When you only visualize success, your brain experiences a sense of premature reward. Neurologically, it's as if you've already achieved the goal, reducing motivation for actual effort. Dopamine, the motivation neurotransmitter, is released in proportion to anticipated reward. If your brain believes the reward is already achieved through visualization, it releases less dopamine for actual action. Let's dive deeper into the neuroscience. What's actually happening in the brain during visualization, and what are the limits? Functional MRI studies show that when you visualize an action, your motor cortex, premotor cortex, and supplementary motor areas all activate, nearly identical to physical execution. These neural pathways strengthen with repeated mental practice, a phenomenon called neuroplasticity. You're literally rewiring your brain through visualization. However, and this is crucial, you cannot develop entirely new physical skills through visualization alone. If you've never played piano, visualizing yourself playing Chopin won't enable you to actually do it. Visualization strengthens and refines existing neural pathways. It doesn't create entirely new motor programs from nothing. You need at least some physical practice to establish the basic neural architecture. Now we arrive at the most controversial question. Can strong visualization create new effects in the universe? Can consciousness directly influence physical reality? Some popularizations of quantum mechanics claim that observation creates reality, and therefore human consciousness can shape physical outcomes. This is a profound misunderstanding of quantum physics. In quantum mechanics, a system exists in superposition, represented mathematically as a wave function psi, which is a combination of multiple states. Here's the key question. What does observation actually mean in quantum mechanics? Does it require a conscious observer? The answer from modern physics is definitively no. Observation in quantum mechanics simply means any physical interaction that causes decoherence. No consciousness required. When a particle interacts with a measurement device, or any other physical system, the wave function collapses. This happens whether a human is watching or not. Experiments with automated quantum measurements, where no human observes the results until much later, show that collapse happens at the moment of measurement, not at the moment of human observation. Let's clarify the famous double-slit experiment, which is often misrepresented in popular discussions about consciousness and reality. In the double-slit experiment, particles pass through 2 slits and create an interference pattern on a screen, suggesting wave-like behavior. When we add detectors to determine which slit each particle passes through, the interference pattern disappears. This is often claimed to prove consciousness affects reality. But the truth is that the detectors themselves cause a physical disturbance. They interact with the particles, transferring momentum and energy, which destroys the quantum coherence necessary for interference. Numerous experiments have confirmed that consciousness plays no role. Automated measurements with data recorded but not viewed by humans still eliminate the interference pattern. Now, there is one scientifically validated way that mental states influence physical outcomes: the placebo effect. This is a genuine, measurable phenomenon. The placebo effect occurs when a patient's belief in a treatment leads to real, measurable physiological changes, even when the treatment has no direct pharmacological action. In pain studies, placebos can produce 55% of the effect of actual pain medication. This is not imaginary. Brain imaging shows real changes in pain processing regions. The mechanism involves expectation triggering the release of endogenous opioids, the body's natural pain relievers. This is a real biochemical cascade initiated by belief. However, the placebo effect has strict limits. It cannot cure cancer, regrow severed limbs, or violate the laws of physics. It works within the body's existing regulatory systems. Critically, the placebo effect demonstrates that mental states influence your own body's internal processes. It does not demonstrate that visualization can influence external physical reality. Given all this scientific evidence, what visualization techniques actually work, and how should they be applied? The most evidence-based technique is mental contrasting, developed by Gabriele Oettingen. This combines positive visualization with realistic obstacle identification. First, vividly imagine achieving your goal. Then, systematically identify the obstacles that might prevent success. This creates a realistic action plan. Implementation intentions are specific if-then plans. Research shows these dramatically increase goal achievement compared to general intentions. The format is, if situation X occurs, then I will perform action Y. This pre-programs your response to specific situations. For example, instead of saying I will exercise more, you specify, if it is 6 a.m., I will immediately put on my running shoes and go for a run. This specificity increases follow-through by 65%. Process visualization focuses on imagining the steps to success, not just the outcome. This is far more effective than outcome visualization alone. Instead of only imagining crossing the finish line, visualize yourself waking up early, putting on running shoes, feeling your muscles work, maintaining pace, pushing through fatigue. Elite athletes have used visualization for decades with remarkable success. Why does it work so well in sports specifically? First, sports involve clearly defined motor skills with established neural pathways. You're not trying to create entirely new capabilities, you're refining existing ones. Second, athletes using visualization already have extensive physical training. They're not replacing practice with visualization, they're supplementing practice with mental rehearsal. Elite athletes combine thousands of hours of physical practice with hundreds of hours of mental practice. The mental practice enhances, it doesn't replace. Third, visualization often occurs during rest periods, when physical practice isn't possible. During this time, the brain consolidates motor memories and optimizes neural pathways. Psychiatry has incorporated visualization techniques into evidence-based therapies. What do clinical outcomes tell us? Guided imagery is used in treating post-traumatic stress disorder. Patients gradually visualize traumatic memories in a safe, controlled environment, reducing the emotional charge. The mechanism is extinction learning. By repeatedly visualizing the traumatic event without the actual danger present, the brain learns to decouple the memory from the fear response. The memory is paired with a safety context, gradually reducing the conditioned fear response through repeated exposure. For anxiety disorders, patients use visualization to imagine successfully navigating feared situations. This is combined with systematic desensitization and real-world exposure. Notice a pattern? Effective therapeutic use of visualization is always combined with actual behavioral change, not used as a replacement for real-world action. Let's examine the biological constraints that limit what visualization can achieve. Understanding these limits is crucial for realistic expectations. When you visualize running a marathon, you don't expend the thousands of calories required to actually run 26 miles. Your muscles don't strengthen, your cardiovascular system doesn't adapt. Physical marathons burn 2,600 calories. Visualizing a marathon might burn 50 calories from increased neural activity. The difference is enormous. Muscle growth requires actual protein synthesis triggered by mechanical stress on muscle fibers. Visualization doesn't create this mechanical stress. Your immune system cannot be visualized into defeating bacterial or viral infections. While stress reduction through relaxation techniques helps immune function, visualization cannot replace antibiotics. Some proponents make extraordinary claims about visualization creating reality. How should we evaluate these claims scientifically? Some claim that visualizing wealth will manifest money, or visualizing a relationship will make a specific person fall in love with you. What does evidence say? People who visualize success often do succeed, but correlation is not causation. These same people typically take extensive action, have existing skills, and work in favorable environments. Both visualization and success might be caused by a third factor: high motivation and willingness to work hard. This is the confounding variable. We hear stories of people who visualized and succeeded, but we don't hear from the millions who visualized just as intensely and failed. This is survivorship bias. Controlled studies, where confounding variables are eliminated, show that pure visualization without action produces minimal results for complex real-world goals. Let's think mechanistically. If visualization were to influence external reality beyond your own brain and body, what physical mechanism could possibly mediate this? Some propose that brainwaves, the electromagnetic fields generated by neural activity, could influence external systems. Let's examine this quantitatively. The electromagnetic field strength generated by your brain is approximately 10 to the negative 12 Tesla at a distance of 1 centimeter from your scalp. For comparison, Earth's magnetic field is 5 times 10 to the negative 5 Tesla, roughly 10 million times stronger than your brain's field. Electromagnetic fields drop off with a cube of distance. By the time you're a meter away, your brain's field is undetectable above background noise. There is no plausible physical mechanism by which these incredibly weak fields could influence objects across a room, let alone across distances, or in complex ways like manifesting specific outcomes. Let's synthesize what the scientific evidence actually supports regarding visualization and outcomes. Strongly supported, visualization significantly enhances motor skill performance when combined with physical practice. The effect size is large and replicated. Supported, visualization techniques help regulate emotions and reduce anxiety through established neurological pathways. This is clinically validated. Supported, mental contrasting. Combining positive visualization with obstacle identification increases goal achievement rates through improved planning and motivation. Not supported. Visualization alone, without corresponding action, achieves complex external goals. The evidence consistently shows action is necessary. Not supported. Visualization creates new effects in the universe beyond the visualizer's own brain and body. No mechanism exists, no evidence supports this. Let me offer an analogy that captures what visualization actually does. Think of visualization as creating a detailed blueprint. When an architect creates a blueprint, it's incredibly valuable. It guides construction, prevents errors, and ensures all components fit together. But the blueprint doesn't build the building. Visualization is your mental blueprint. It organizes your actions, makes them more efficient, and helps you anticipate problems. But you still need to gather materials, do the work, and build the structure. A detailed blueprint makes construction faster and better. Similarly, detailed visualization makes goal pursuit more efficient and effective, but neither replaces the actual work. Based on all this scientific evidence, what are practical, evidence-based recommendations for using visualization? First, focus on process visualization rather than pure outcome visualization. Imagine yourself performing the specific actions required for success. Second, always combine visualization with concrete, specific action plans. Use implementation intentions. If X, then Y. Third, Include obstacles and challenges in your visualization. Mental contrasting is more effective than purely positive imagery. Fourth, use visualization to supplement physical practice, never as a replacement. The ratio should be roughly 5-to-1, 5 hours of physical practice for every hour of pure visualization. Fifth, visualize factors within your control, your own actions, decisions, and responses. Don't visualize controlling external factors or other people's choices. Finally, let's consider why this scientific understanding matters philosophically and practically. Understanding the real, scientifically validated effects of visualization is empowering. You know what tools actually work and can apply them effectively. Equally important, understanding the limits prevents false hope and wasted effort. You won't spend years visualizing wealth while taking no practical financial steps. This understanding respects the genuine complexity of the universe. Reality doesn't bend to our wishes, but we can shape our own skills, choices, and responses. The universe operates according to consistent physical laws. This consistency is what makes science possible, what makes engineering work, what allows us to build technology and cure diseases. If consciousness could override physical laws through pure visualization, the universe would be chaotic and unpredictable. Science would be impossible. So what's the final verdict on visualization and success? The answer is nuanced and firmly grounded in evidence. Visualization is indeed a powerful cognitive tool. It strengthens neural pathways, enhances motor learning, improves planning, and supports emotional regulation. It works through well-understood neurological mechanisms, neuroplasticity, motor cortex activation, and prefrontal planning circuits. To achieve external goals, visualization must be combined with sustained, intelligent physical action. There are no shortcuts here. Visualization cannot create new effects in the universe beyond your own brain and body. It cannot violate physical laws or influence distant systems. The real magic isn't in mystical forces or quantum consciousness. The real magic is in your brain's remarkable plasticity, its ability to learn, adapt, and optimize through mental practice. If we had to write an equation for success, it would be success equals visualization multiplied by action multiplied by persistence. Remove any factor and you get 0. Embrace the science. Embrace the reality that the universe is lawful and consistent. And embrace the fact that effective visualization, combined with determined action, genuinely enhances your probability of success. Thank you for joining this rigorous scientific exploration of visualization and its effects. The evidence is clear. Visualization is a valuable tool, but only when used correctly and combined with real-world action.